We're here at the Anchor offices in Shenzhen, China, inside the eufyMake lab. And we're gonna see how they make the eufyMake UV printer E1, which is a personal desktop UV printer, which makes incredible full color, full texture prints like this one. In 2019, we saw how industrial UV printers are made, but they're huge. eufyMake has managed to shrink this amazing technology down to something you can fit on your desk. A huge thanks to them for sponsoring this video and giving me such deep access to their factories. Let's go to the first step, which involves a molten pot of aluminum. This is the main frame of the machine. The x-axis goes here. This is the z-axis here. And this top part is die-cast aluminum. And we're at an aluminum die-casting factory. This is my first time seeing this process, and it's amazing. These are the raw parts that are coming out of the machine. It's basically a molding process, but for molten aluminum. So there's a pot back there where they're dumping in ingots, as well as recycled excess material that comes off the parts. And then they have a scoop, a dipper there that's dipping in, getting a scoop full of liquid metal, dumping it in a ram, and then they're ramming it into a mold, a tool made out of tool steel. This is obviously a very hot, very noisy, very sweaty process for the worker that's pulling parts out of the machine. You'll notice all these bars here. This is the same part as on this fully assembled frame. So they cut out these middle bars using CNC, the pressure that holds the tool together, and then the ram that rams the metal in are around 1,250 metric tons, which is incredible. This also consumes a ton of electricity and gas to keep that pot of aluminum molten. They keep it warm 24/7, they never turn it off. It takes 12 hours to heat it up from a cold state. The steam you see coming off is them spraying the inside of the mold with a mold release so that the aluminum doesn't stick to the inside of the mold. We're here at the CNC factory. This is the die-cast part straight out of the die-casting machine. And the first step is they cut out all of these rails so it looks like this. And then they send it off to a sandblaster to clean it up a little bit, bring it back to this machine here, and mill a few things on the bottom. These are little inserts for the lasers to align the print head and the part. So this next step is milling out everything on the bottom here. So these dished out parts for the laser for aligning the part in the machine, all the contact points here. Now this is what's called a 3+2 machine. So it actually can move the part around as well as the milling head. So it can tilt it to get to various areas on the part. This last step, they mill this groove here where the linear rail goes for the x-axis. Really crucial to get this accurate because it affects the accuracy of the entire machine. They also do this top part here, this top part here, and they also tap the holes for screws because everything's gonna get mounted to this in the assembly process. And then lastly, there's a fourth step. They're also running it on this machine, but it's a refixturing. They're just milling this little face here. So this is the QC room, and they have this giant X-ray machine for X-raying the parts to see if there are any bubbles in the metal, which will affect the quality or the strength of the part. And so she's running it here. She's got a picture of the part here, and then you can see the image here on the screen. And they can see she had a picture of a failed part that just looked like Swiss cheese. This here is showing the porosity in that part of the part where there were some bubbles or something. And that would be a part that would be immediately rejected and sent back to the die casting factory. So the parts come in here from the die casting factory, they x-ray them, make sure that they're high quality, then they get sent out to the CNC mills to be finished. Next, the parts come to their QC room for measuring all of the dimensions after the milling. So this is a CMM machine. It uses a ruby tip on the end of a probe to do extremely precise measurements of set points on the part to make sure that the dimensions are exactly what they're supposed to be. We're here at the injection molding factory where they make all of the plastic parts for the machine. And this is the X-axis cover, but they make all the different parts, including the outside of the machine here. This is one of their injection molding machines, and it is hot in this room. This part is hot, everything is hot and humid in here. The action starts back here. Upstairs is the raw plastic pellets that come down this tube into the hopper here. And then they get fed by a lead screw into the machine, which melts the pellets into a homogeneous mixture of molten plastic and then rams them into the mold with this lead screw. So this lead screw starts from a relatively deep cavity and it increases the pressure as it goes down. That's all happening here in the machine. The cycle time's about a minute, so they're making about 60 parts an hour. They have a piece of tool steel that's carved out into exactly the right design for this part. So right now, the plastic is being forced into the mold. When the mold opens, this robot arm will reach in, grab the part, separate it from the sprue, which is here. This is the remnant of the plastic being forced into the tool. So here's the part coming out right now. That's the waste sprue or runner. This is being placed on the conveyor belt. And it slowly comes down the conveyor belt as it's being cooled by the fan. They're pretty hot when they just come out. And the worker here, she's inspecting to make sure there are no defects, removing any little flashing or extra plastic, and then bagging them so they don't get any scratches or other defects, and finally placing them in a box to go to the assembly factory. We'll see that in a little bit. One thing that's worth noting here is all of the standard operating procedures, SOP, and standard inspection procedures. All of these 6 different pieces of paper outline the standard operating procedure and the standard inspection procedure for this specific part. There's an entire sheet here just showing what she's supposed to be doing. There are pictures here showing how things are to be wrapped in plastic, how they are supposed to be stacked in the box. Quality is everything, so it's really important she's just not making up stuff as she goes along. And then have the worker down there, they have 2 machines right now making this part. They want to make sure that everybody's doing the same thing and it's exactly what the engineer specified and what's getting checked by QC and QA. This is the top cover of the machine, and I just wanted to show a bigger part. They're not making this today on any of their machines, but this is the tool for it. And it would go on like this here. I'm not going to snap it all the way on, but this part has a finish on it. It's sprayed on at a different factory. So they mold it here, send it out to another factory to get this silver coating on it. The parts all come together here for final assembly. We're at Luxshare, which is a tier 1 contract manufacturer who makes a ton of different products for Anchor. They're an amazing, enormous company that's really good at this. But they are still ramping up the production line. They're running just a few units a day, working out all the bugs. So I'm gonna get a chance to do something that I've always wanted to do and I've never gotten the chance, which is I get to be a factory line worker for the day. I'm gonna try out a bunch of different stations here and try my hand at different processes. We're gonna start with sub-assemblies and then work our way to building a full finished machine. Let's jump into the first step. So we're putting in linear bearings here for sliding on the rails. And then it goes in the jig into this press. And then I need to get some more. Don't fire me for dropping stuff on the floor. Now I'm only supposed to touch the bearings with my gloved hand. Now, put in 4 set screws. We have a proper screw gun. Oh, that's really satisfying. It just like clicks into place. All right, I'm gonna send it on to the next worker. Well, I guess I'm the next worker. So I'm gonna put it on this jig here, and then I'm gonna put in a whole bunch of different parts. The various pieces for the latching mechanism for this to hold the build plate on. Next, I gotta put a little bit of some grease. Next, these shafts go in here. One more screw here, and this is the set screw for this little guy. Oop. Oh no, I'm in real trouble now. Jesus, I got it. They're gonna fire me. All right, on to the next step. Okay, so the previous step put in this switch and hooked up the belt. So now the bed locking mechanisms that I put in work when you move the lever, like that, and this connector moves in and out. So I'm now gonna put it in here, and my job is to attach the lead screw. Onwards. All right, so now we're marrying the piece we assembled before with another die-cast piece here. This is the bottom holder. This is where the lead screw fits in. We've got a couple circuit boards that have been added with wires. And we're good to go. Lastly, this is the QA step. And so he's loading into a custom jig that's doing the functional testing. He's plugging it in. And then I believe it runs the motor here. So scanning the QR code. The QR code's unique to each part, so they can track, did it get QA'd properly? What batch was it in? What day did it get produced? Running the motor, making sure that moves properly. And then down here, she's doing the aesthetic testing. So she's checking that there are no scratches, blemishes. It looks like she's got a bottle of solvent and a little rag to wipe off any fingerprints, make it look all nice and pretty. And then these will head over to go into the finished machine. So this is the first step in the print heads. These print heads come in directly from the supplier, and she's putting on a QR code, and then this laser marking machine, which is a fiber laser with a galvo head, is marking the serial number for the print head itself, so they can track this through the rest of the production process all the way into the finished machine. She's also putting a piece of protective film over the print head with a little drop of some sort of liquid to keep it moist and protected as it goes through the manufacturing process. So this is the print head, and now we are going to install these holders for the print chamber. So the print chamber maintains good ink pressure right at the print head. So the first step is to remove these rubber protectors here. Now there are 6 different print heads. I think it is CMYK, so cyan, magenta, yellow, black, white, and then glossy, like a clear, transparent gloss. This is quite cool. It is a computer-controlled CNC glue dispenser. It's a 2-part epoxy with a mixing tip here that's a series of spirals, and as the 2 parts go down the spirals, they mix, and then they come out the tip. So this goes in here. I hit the green button, and away we go. Okay, so we've got these, and I was told these 3 prongs have to be forward. Just making sure I'm getting them seated all the way in there. And finally, they go in one of these clamping jigs here, which are all custom. And then we start the timer here. So these also track temperature and humidity, and it's, again, all about repeatability to make sure the epoxy dries the same way every single time on every single print head, and that they can track it over time. These will cure for 24 hours and then head on to the next step. Once the epoxy is cured for 24 hours, they bring the print heads here to test whether it's airtight and ink tight ultimately with this test jig. So they're using air pressure to test if there are any leaks around that epoxy to make sure that they're going to be able to maintain the right pressure to the print head. So the guy over here is putting in the cables that attach to the print head. And this station here is another glue dispenser, but this time it's dispensing this Loctite potting compound. And this acts as a waterproofing for all the connectors to keep any ink or solvent off of them. You tuck this cable here, and then we hit go. This is so cool. I have no need for one of these, but I really want one. Okay, there you go. It's a little bit stringy. They have put a piece of protective tape over the print head, so this compound isn't getting in there. And then the next station here is he's doing some manual application of the same compound in places that the machine has a hard time reaching. So just touch-ups. We're on the other side of the clean room line now, same room. And I just wanted to point out the humidifier back here is pretty normal in these rooms. It's just to add humidity to knock dust out of the air and keep it cleaner in here. This is the holder for the solenoid valves to switch between the ink and the solvent that goes into the print head right at the print head, just before it, for their jet clean system. One of the big challenges with UV printers is keeping the print head clean, prevent it from clogging, and the worst case scenario is having the UV ink cure in or on the print head, and at that point, the whole thing is just toast. So, very important part of the system. This is potentially a real game changer for this printer to really reduce how much maintenance you have to do. These are numbered, they've laser marked all of them, and I have to get them in the right order. So that goes in here. And don't worry, they are checking every single one I do to make sure that nobody ends up with a bum printer that I made. They said put a little twist in this to kind of hold everything in place. I put it in this jig. That holds it in. This flips over. God, these jigs are just beautiful piece of stainless steel. I get my screws and my screw gun and I put them in each one of these numbered holes. And I think we're good to go. Beautiful. And we'll send it on down the line. So next, I'm gonna put all of these ink chambers onto the back of the solenoid valves. Now, the role of the ink chambers is to maintain a steady pressure at the print head to make sure that the ink is flowing the way it should be. This is a ionizing air snake, according to the label. And it's just for cleaning off any excess dust from the factory. These go in like this. It's really cool seeing this come together and get built up piece by piece. Usually I'm doing this in reverse, taking things apart to see how they work. But it's cool to get to build something. All right, this needs to go in here in this press to make sure everything is pressed in with the correct amount of force. Now we're gonna put the cover on. There, beautiful. And then finally, we'll put in some screws. It's really cool to build this up from scratch. You know, I've taken so many things like this apart ever since I was a kid, and getting to put it together is a really special experience. I believe that is good to go. And I'm just gonna put it right here for the next woman when she's back. So now I'm assembling the UV light assembly, and the UV light is what cures the ink once it hits the object that you're printing on. First, this goes into the holder, and then I am putting in like a light pipe lens that slides in here. So next I'm gonna use this UV cured glue dispenser to put a little bit of UV glue. This is gonna go into the UV light to cure for 4 seconds or so. Ooh, it's warm in there. So this is like a carbonized sticker. And I think this is for improving heat transfer on the heatsink. It's pretty good. And then these go in here. Onwards. This is the partially assembled holder for the print head assembly. Has the tubes coming in here that will be filled with ink, control board. This is the UV light assembly that we put together. And then there's basically just a plastic slot that the print head goes into. So we've got the 2 ribbon cables here coming off the board. They go through here, down through there. Now, the tubes get pressed into these curving slots, which are really gorgeous. Put on another plastic strip here. Now, adjust this length. That also gets adjusted onto these pins. Hold this all together while I clamp it in. I put on these covers. These are protectors for protecting the tubes. Apparently, they found out that in testing that the tubes bumping into the wall of the machine was wearing them out over time. So they designed these clips to go like this. There it is. So this is the finished holder for the print head. These are the finished print heads. So this is the moment of truth, marrying everything together into a full finished holder print head assembly. So this is how, as a user, you would swap your print head if you decide you need to get a new one. This just slides in here like that. That assembly slides down, goes in this jig. Now, obviously, you wouldn't have the jig at home. And now we have a fully assembled print head holder assembly. This is ready for testing over here. So this is a pretty complicated test jig. This is testing the whole assembly now. One of the big things they're doing is air pressure testing again. Now, we had done air pressure testing on just the gluing. This is another set on the whole assembly to make sure that there aren't going to be any ink leaks or leaks in the solvent system. It looks like there are pressure gauges here, so 8 pressure gauges, and then they're doing some functional testing on the print head as well, and then all of the boards and sensors. From a technician perspective, it's pretty automated. He just plugs everything in and then hits go, and it goes through a series of checks that takes, I don't know, a few minutes at least. Once he signs off on it, then it goes back to the woman back here, and she's doing a final visual inspection to make sure everything looks right, there are no scratches, there are no blemishes, and then it gets packed into these foam crates to go over to final assembly to be put in a printer. So this is one of the camera testing stations. This is the top camera that sits in the top cover of the printer, and it looks down on whatever you're gonna print on so that you can align it with your design so that it prints in the right spots. They call this the snapshot camera. And this testing setup is to test to make sure there are no dead pixels on the camera and that the resolution and clarity is what they expect. Basically a QC check on the camera. Here, this jig is doing camera calibration. So because this camera needs to match where the print head is gonna print, there can't be any distortion. So they've chosen a camera that is already low distortion, and then they point it at this test grid and then figure out what distortion the camera does have and match that to the serial code so that distortion compensation can be programmed into the firmware for each printer that's custom to the camera that went into that printer. Which, frankly, as a software engineer, that blows my mind. I'm not even quite sure where I would start building a system like this. It's really impressive. So this is the x-axis, which we saw being die cast, and then we saw it being milled out and finished up. And now I'm putting in the laser measurement system that measures the height of the material that we're gonna print on. And these are the laser modules that go in. I've already put in the left one, I'm about to put in the right one. They're on springs and they have all sorts of set screws to calibrate them. They go in an X across here, so this is the laser source, and then this is the receiver, and there's source and receiver here. And the idea is that as the bed goes back and forth underneath this, it can measure the height of the material all across the bed. The goal is to find the highest point so that the machine can set the print head just above that to get as close to the material as possible without crashing into it. And right behind the camera is the guy who designed this entire part and the jig. So he's watching me very carefully to make sure I do it right. Put this jig back here. So this is just an optical end stop. And we'll send it on to the next station. Now we're gonna align the lasers. So this is a very clever jig. I'm gonna turn on this laser. And this white backdrop here shows me where the laser is currently pointed. And what I need to do is adjust the 2 set screws I just put in to put it in the hole of the detector. So I'm gonna use the right to left one. I'm gonna go up and down on the vertical set screw. And I'm there. So I know when to stop when the green light goes on. That one's good to go. Turn that off, and then I can do the left one. At this station, we're putting in the x-axis linear rail, as well as the motor that moves the x-axis back and forth with the print head. So this is super crucial to be very precise. So this is the linear rail. So this is the idler pulley for the belt that goes on this side, and then the other end goes around the pulley on the motor here. And that belt is what moves the x-axis and the print head back and forth. So this is the stepper motor for the x-axis. Good to go. So here is the final testing phase. They're testing how parallel the x-axis linear rail is to the frame. So they've got a really precise laser measurement head here that clamps on to the linear rail, and they do a measurement at this side, and they slide it over to that side and measure that they're the same. And then lastly, this arm comes down to test the tightness of the belt. With that, this is declared good to go and to be installed into a final machine. This is the first step in putting the printer together. We've got the Z-axis left side and right side, and the X-axis top, and this is the jig for fitting them together. Now, this is a two-person position, so we're gonna put these on. Now we're attaching the X-axis to the Z-axis, to the sides, and then he's putting in 4 smaller screws that are also attaching down into the sides. This goes on top here like this. They put in some screws. I'm gonna let them finish this up, and we'll pick it up a little bit further down the line. Next, we're gonna put the bottom cover on, as well as the print head tray for cleaning and whatnot. That goes in here. Here, the printer. Have you ever wondered why it's hard to take certain electronics apart? I think this might be the answer. This is really cool. An offset screwdriver. Okay. Now they're working on Lazy Susans, which makes this so much easier because this printer is getting heavier and heavier as we go on. We're doing hinges. Now we're gonna add in the print head cleaning tray. So this has a place for the print head to flush ink and solvent, and it also has this, so it can move back and forth. It also has this wiper bar here, which has a little rubber edge for wiping off the print head. That gets attached under here. Next, we're gonna add the Y-axis, the bed. And this goes in here like this. And then we push down the Z-axis. And this is what's gonna hold the bottom of the Y-axis. I'm gonna put in the Y-axis assembly. This is just another nice cover. If you're anything like me and you've taken apart your electronics, you'll know how frustrating it is to remove something that has those snaps. But look how easy it is when you're on the factory line putting it together. And then lastly, we put in the cover that hides all the electronics here. Ta-da! Next, we're gonna put on the holders for all of the bottles of ink. Also, you'll notice there's a motor here. This is really interesting. So the motor is for the white inkwell, because apparently the particles in the white ink tend to settle to the bottom. So they've actually created a magnetic stirrer, which is used a lot in chemistry labs. The idea is you have a motor with a magnet attached to it, and then inside your liquid, inside your container, you have a magnetic stir bar, which is just a magnet, usually coated in like Teflon or something like that, some non-reactive plastic. That way you don't have to have a motor shaft that runs through your container. You just use the magnetic field to match the magnet on the motor with your magnetic stir bar. So this is the magnet in the motor. This just goes here. Now I'm gonna put in a cable here that goes to the control board for all of the ink cartridges. Now, they did say that you can only use eufyMake ink in this, and that these will authenticate against the ink cartridges. So next, I'm gonna put in the tubing. So this gets pressed into this track like so. Beautiful. Onward. I'm gonna install some pumps, and eventually we're gonna install the print head here. These are actually not pumps, they're sensors. They're 1 milliliter chambers that have a solenoid valve at the bottom, and they're using these to measure the amount of solvent and the amount of moisturizing liquid that go into the print head. So they fill it up, then they release it, and they know 1 milliliter has gone in. Let's see, I gotta plug these in. We're gonna put this pressure sensor. This maintains the correct air pressure for all of the ink cartridges. Time for the print head. So, next, We're gonna put on the top cover, which has the camera here, the snapshot camera, it has the main board, but we have to put in some other things first. So these are light pipes, and light pipes are pretty cool. Light pipes are made out of like an acrylic plastic, and they conduct light from an LED, in this case from down here, all the way up to the top where you can see it. So these go in here, and these are, I imagine, indicators for each tank of ink. Now, the top cover. Now we've got the flat ribbon cables from the print head. So those go up here. Okay. Now we're gonna put on the covers. So front and back covers. I don't know which one this is, whether this is considered front or back, but it goes on here. I swear to God, I was told to do this. Not only was I given permission, I was encouraged. Same sort of deal. It's starting to look like not only a finished machine, but like a UV printer. Now we're getting to the testing part of the line. This machine is more or less done. The first testing step is visual inspection. So he's just going through and checking, does it look right? Are the cables in the right spot? You know, are there any marks? This test setup is, again, a pressure test, but this time with the entire assembled system. So the test rig has these cool ink containers that have pressure tubes going into them, two pressure sensors over here. They're just testing to make sure there are no leaks in the entire system now that it's all put together. Everybody's scanning QR codes. Every test this goes through to record the test results for every single unit, every single serial number that goes through. Part of this is to make sure that none got missed, but also part of it is to make sure that if there is an issue, they can trace it back to, you know, what batch did it come from, who assembled it, whatever. So this is the first complete machine functional test. Do the motors move? Do the sensors work? Etc. And finally, the printers come here for burn-in. They run them for a few hours to make sure there are no problems. Interestingly, one of the things they're not doing on every machine they produce is running a full test print like this. They said, yes, we could run test prints on all the machines, but that would mean that we're injecting ink into all of the tubes and the chambers and the head. It's really hard to clean all that back out. And they're worried that during shipping, the machine's gonna get rattled around and that ink will get flung everywhere and make a mess inside the machine. So they are not running test prints so that you get a clean, gorgeous machine when it arrives. However, I wanna see this machine in action for real. This is a pretty amazing test print. I mean, the quality here is gorgeous, but I wanna see it on some cooler designs. So we're gonna head to the Anchor main office, to their test lab, and see what this machine can do. I'm here with Timothy, who is the product manager of the eufyMake UV printer E1, and we're going to take a look at a finished working printer, right?
Yeah.
Let's do a phone case.
Yeah, sure.
Since Strange Parts is often about phones. Yeah, we were talking maybe do a Strange Parts logo.
Yeah.
So this is your software here. So this would be similar to like what you see in the 3D printing world of like you can download things that are already pre-designed, ready to go.
So the first thing we need to do is to measure the height of the phone case.
Right. Okay.
So you can see the phone case is transparent.
Yep.
Yeah. So our dual laser system can recognize the transparent.
Got it. Oh, so now do I just line the logo up?
Yeah.
That's cool. Just press start.
Yeah.
Okay. I see some action here.
Yeah. It's printing now.
Do I need to be careful not to look at the UV light?
Yeah, the UV light, the whole printer have passed the TUV certification.
Oh, okay.
And the light is not harmful to your eyes.
Oh, great. Okay.
Yeah. But
So it's safe to look at.
if you long time directly seeing the UV light,
Yeah.
I suggest you wear our glasses.
All right. So can I take it out?
Yeah.
All right. Awesome. And it's fully hardened. It doesn't require curing or anything. It's immediately touchable. Look at that. It's pretty sexy.
Yeah.
You guys have more attachments than just these two beds, right?
Yeah.
So you can also do round objects like mugs and tumblers and things.
Yeah.
Yep. So you just pop that lever, that swaps out.
Scotty, you know, in industrial UV printing,
Yeah.
the flatbed and direct to film and rotary are 3 different machines.
Completely different machines,
Yeah.
right? So it's cool to be able to do them all in one machine.
Yeah.
Okay.
Loading is very simple. You just attach to the front and the back.
Yeah.
Load this.
Oh.
That's cool.
Okay.
We have
What do you got?
a lot of templates here.
Yeah.
You can choose when
What's
you...
something like mountain related? Since
Yeah.
we're running the new channel Electric Ranch.
How about this one?
That one works? Yeah.
Yeah.
Let's do that.
Shrink it smaller.
Okay.
And
Great.
it's done.
Okay. Awesome. Let's print it. So now it's going to calibrate.
Yeah.
Okay. Oh, it tilts. I was wondering how that was going to work because the x-axis is just parallel to the floor.
Yeah.
And the whole rotary insert tilts. That's cool. As we're sitting here doing this, it occurs to me that, I mean, I could make Strange Parts merch with this in my workshop without having to send it out for a lot cheaper than it would cost me to have somebody else do it. And I could ensure quality and like, this is a game changer. And it's ready to go.
Yeah.
Wow. Okay.
Yeah.
All right, it's starting. So what's the ink story here, right? We've talked a little bit about ink.
Yeah.
We know you have to use eufyMake, right? You can't use other people's ink.
Yeah.
Why?
I think there are problems with the third-party ink. The first is the UV ink now has no standard. So they do different damage to UV printhead.
So you guys are worried about someone putting a low quality ink in here or an ink this wasn't designed for damaging their printer and then being upset about that.
Yeah, that's the first question. The second question is we are printing 3D texture and other high quality prints. Most of the substrate can be very expensive. I see our beta tester print a pattern on their laptop.
Yeah.
So you use a third party UV ink and it won't print well each time. So you don't want to ruin your substrates.
So it's a matter of reliability. If you're printing on a $2,000 laptop, you want it to be successful, guaranteed. And if you use a third-party ink, then maybe you have a likelihood that it'll fail.
Yeah.
And there's not really a way to clean this off a laptop. It's really, really stuck on there. While this is printing, you guys have another accessory you haven't talked about publicly at all yet, right?
Yeah.
This is huge.
Yeah, we developed a new accessory, the roll to film printing.
Okay. So this material comes on a roll.
Yeah.
And then you're printing on it as it comes off the roll?
Yeah, it's printing out as a flat.
Oh, this is like a self-adhesive vinyl. So this is a 3M material. So this is basically a giant sticker?
Yeah.
Like a decal or something?
Yeah.
That is amazing. Is this the max width?
Yeah, the max width is similar with the printer is like 300 millimeters.
Okay, you can do 300 wide. What's the max length?
10 meters, I think.
Wow. Okay, so like 30 feet. Let's go look at some of the other samples back there.
Okay.
Yeah. So you guys have a ton of amazing samples here. Some of the really cool ones that we saw. This one I think is my favorite, and this is on what, like a plywood, birch plywood backing. This is just spectacular. It's got a lot of raised detail, and then this has the glossy coating on top of it.
Yeah, it has glossy vanish effect.
These are magnets?
Yeah.
Oh. And this is printed on the backside.
CMYK first, then white.
Oh, that's so cool. This is really pretty. So is this kind of max height for your texture? It's about half a centimeter.
Yeah.
So 5 millimeters.
Yeah.
I mean, this is approaching like the level of like doing a 3D print in terms of stack up. That's gorgeous. These are stickers?
Yeah.
Wow. So then this comes off.
The patterns stay on the coaster.
Dude! Okay, that looks great. So this is a way to put things on irregular shaped surfaces.
Yeah.
You don't have to only print on either flat surfaces or on round tumblers. Metal. So these are like sign metal. This is the film.
Yeah.
And then no glossy.
Yeah.
These are particularly nice just given how textured they are. They've got a really nice buildup of texture. What do we got here? We got a phone case. Oh, this is on wood. Oh, this is laser cut wood.
Yeah.
Oh my God. What is this? This is laser cut wood?
Yeah, laser cut wood and print on that layer by layer.
Dude, and you guys are just doing solid colors, but it's still spectacular. So this was a roll of canvas, and then you put it on a metal backing.
Yeah.
And then here's some examples of your tumblers and things. All right, let's go look at that print that we've got printing. It looks like it's almost done here.
Yeah.
Let's go take a look. Dude, looks pretty good. So Timothy, this is amazing. I can't wait to try one out in my workshop. We're gonna put up an unboxing and review video on my second channel, Stranger Parts, in the next week or two. So subscribe to that channel if you haven't already so you don't miss that. But what should people do if they want one of their own? You're running a Kickstarter right now.
Yes.
Yep, and we'll put a link to that down in the description to tell them that I sent you. Go check it out. I think these are about to change things in the making world in a big, big way. Timothy, thank you so much for having me, for giving me such deep access to your factory and showing me all about this product. I'm blown away.
Yeah.
Thank you again.
Thank you for your efforts.
Absolutely. I'll see you guys again soon.